Good morning, students. Again, recommencing our topic today, we will learn about concave mirror. So far, we have discussed the common terms and definition related to a spherical mirror. I think you can recapitulate the definition of aperture, pole. Then we have defined center of curvature, principal focus, radius of curvature, and focal length, so on. Continuing the topic today, we will learn in detail about concave mirror. In fact, today we will define principal focus and focal length of a concave mirror. We will define why concave mirror is called a converging mirror. We will do the rules of image formation in concave mirror, and we will lastly go through the image formation in case of concave mirror. Okay, and lastly, again, we will study about the use of concave mirror. Listen carefully now. Concave mirror. How you have defined concave mirror? A spherical mirror having inner surface reflecting and outer surface reflecting is called concave mirror. This is a spherical piece of glass. Its outer surface have been coated. Its inner surface is reflecting. This is an example of concave mirror. How you have defined concave in previous lecture? You have defined concave mirror as a spherical mirror having inner surface reflecting and outer surface reflecting is called concave mirror, which is the front part of concave mirror, inner part. This is the front part and this is the rear part. Okay. Now, next. Now, while studying concave mirror, first we will define principal focus and focal length of a concave mirror. Geometrically, you have defined principal focus as the midpoint of radius of curvature on principal axis, which is called principal focus, and the distance between principal focus and pole, the distance between pole and principal focus on principal axis is called focal length. Now, based on the characteristics of concave mirror, again we are defining principal focus and focal length of a concave mirror. Observe. And focal length. Consider here. Let a concave mirror is taken. This is a concave mirror. Why this is a concave mirror? Its inner surface reflecting and its outer surface is rough. M dash is representing the aperture of the mirror. The length of the reflecting surface is called aperture. Let this be a pole. This line is representing principal axis. Yes or not? Let this be a center of curvature and this be the focus. Now I am defining principal focus strictly for concave mirror. Consider from source of light, a parallel beam of light is falling on concave mirror, which is parallel to principal axis. From a ray of light, from a source of light, parallel beam of light are incidenting on concave mirror. Concave mirror is also called as converging mirror. Why concave mirror is converging mirror? You will know. How? We will discuss. In case of concave mirror, any ray of light parallel to principal axis will always converge at a point on principal axis and that point will be focus. वो सभी रे ऑफ लाइट जो पैरेलल है प्रिंसिपल एक्सिस के, ये राइट, ये रे ऑफ लाइट, ये इनफाइनाइट रे ऑफ लाइट, ये सभी किसके पैरेलल है? प्रिंसिपल एक्सिस के. जब मिरर से रिफ्लेक्शन हो रहा, ये सभी रे ऑफ लाइट प्रिंसिपल एक्सिस के एक पॉइंट पे कन्वर्ज करता, उसी पॉइंट को हम क्या बोलेंगे? फोकस. जो इनफाइनाइट रे ऑफ लाइट है, रिफ्लेक्शन के बाद प्रिंसिपल एक्सिस के एक पॉइंट पे कन्वर्ज कर रहा, और इसलिए कॉन्केव मिरर को हम कौन सा मिरर बोलेंगे? कन्वर्जिंग मिरर. ध्यान से देखो एक बार और. ये कॉन्केव मिरर है, ये लाइन प्रिंसिपल एक्सिस को रिप्रेजेंट कर रहा, सोर्स ऑफ लाइट से इनफाइनाइट रे ऑफ लाइट आ रहा जो पैरेलल है. किसके पैरेलल है? प्रिंसिपल एक्सिस के. ये सभी रे ऑफ लाइट जो किसके पैरेलल होना है? प्रिंसिपल एक्सिस के. वो सभी रे ऑफ लाइट जो प्रिंसिपल एक्सिस के पैरेलल है, कॉन्केव मिरर से रिफ्लेक्शन के बाद वो प्रिंसिपल एक्सिस की एक पॉइंट पे आके कन्वर्ज कर रहा, और उसी पॉइंट को हम क्या बोलेंगे? प्रिंसिपल फोकस. और जो डिस्टेंस होगा पोल और फोकस के बीच में, उसी डिस्टेंस को हम क्या बोलेंगे? फोकल लेंथ. Now, how could you define the principal focus of a concave mirror? Listen, any ray of light parallel to principal axis in case of concave mirror after reflection from the mirror converge at a point on principal axis and that point is called principal focus. वो सभी ray of light concave mirror के केस में जो पैरेलल है principal axis के, रिफ्लेक्शन के बाद principal axis के एक पॉइंट पे कन्वर्ज कर रहा, उस पॉइंट को हम क्या बोलेंगे? प्रिंसिपल फोकस. और जो डिस्टेंस होगा पोल और फोकस के बीच में, इसी डिस्टेंस को हम क्या बोलेंगे? फोकल लेंथ. Now you can easily define principal focus and focal length of a concave mirror. How could you define principal focus of concave mirror? Any ray of light parallel to principal axis in concave mirror after reflection from the mirror converge at a point on principal axis in front of the mirror, and that point is called principal focus, and the distance between pole and focus on principal axis is called focal length. Yes or no? Now, why concave mirror is converging? Of course, concave mirror is converging because all those rays of light which are parallel to principal axis after refraction, they converge at focus. Infinite parallel ray of light are converging at a point. Concave mirror will be called as converging mirror. Which mirror is converging? Concave. Why concave mirror is converging? Because all those ray of light which are parallel to principal axis and concave mirror after reflection, they converge at focus. Concave mirror will be a converging mirror. Yes or no? Any problem? Listen, a concave mirror have real focus. What is the meaning of real focus? What is the meaning of virtual focus? The focus of convex mirror is virtual. The focus of concave mirror is real. Why the principal focus of concave mirror have been termed as real? Because after reflection from the mirror, all those rays of light which are parallel to principal axis are actually intersecting in front of the mirror at a point on principal axis. The actual intersection of light is happening at focus. The concave mirror have real focus. Okay, the same will be not case with the convex mirror. We will discuss it later. And convex mirror we have virtual focus. The principal focus of concave mirror will be real. Why concave mirror have real focus? Because the reflected ray of light, which are parallel to, for an incident ray which are parallel to principal axis, meets actually in front of the mirror at a point on principal axis. Actual intersection of light, actual converging of light takes place at focus, and thus the concave mirror have real focus. One more thing. You should not down dash. A spherical mirror can have focal length positive or maybe negative. A concave mirror always have negative focal length, while a convex mirror always have positive focal length. We will discuss in the sign convention. I will give you the proof why the concave mirror have negative focal length, why the convex mirror have positive focal length. We will discuss in the sign convention, but you should not down it. If a spherical mirror have negative focal length, the mirror will be concave. If a spherical mirror positive focal length, it will be convex. Suppose a spherical mirror focal length minus 15 cm. The mirror, what is the nature of mirror? The mirror will be of course concave. How could you conclude? Because the focal length is negative. Whenever a mirror have negative focal length, it indicate a concave mirror. Whenever a mirror have positive focal length, it will represent a convex mirror. What you have learned so far today? You have learned about the principal focus and focal length of a concave mirror. Then you have understand why concave mirror is converging mirror. Then we have learned why concave mirror have real focus, and always the concave mirror have negative focal length. I am concluding it. Listen, how could you define principal focus and focal length of a concave mirror? You can explain it like this. All those rays of light which are parallel to principal axis and concave mirror after reflection from the mirror converge at a point on principal axis in front of the mirror, and that point is called principal focus, and the distance between pole and focus is called focal length of a concave mirror. Yes or not? Why concave mirror is converging mirror? Because all those rays of light which are parallel to principal axis after reflection from the mirror converge actually in front of the mirror. Thus concave mirror is called converging mirror. Why concave mirror have real focus? Because the actual converging of reflected light takes place at focus. Concave mirror will have real focus. And of course you can also say it like that. This because the principal focus of concave mirror is lying in front of the mirror. In front of the mirror it will be a real focus. And lastly you have learned that a concave mirror have negative focal length. If a spherical mirror have negative focal length, the mirror will be concave. Okay. Any problem? Now, going forward, now we will study about the rules of image formation in concave mirror, and after that we will study about the image formation in concave mirror. Okay. Now I think you can easily define the principal focus and focal length of a concave mirror. You are also able to define why concave mirror is converging mirror. You can also say that why concave mirror have real focus. Now we will go through the next concept, rules of image formation in concave mirror. Listen, basically as in syllabus there are 4 rules of image formation in concave mirror. Listen, what is rule 1? This is a concave mirror, yes or not? This is pole, this line represents principal axis, this is focus, and this is center of curvature. Observe. Rule 1. What is rule 1 of image formation in concave mirror? All those rays of light which are parallel to principal axis, I have discussed it. All those rays of light which are parallel to principal axis in concave mirror after reflection from the mirror passes through focus or converge at focus. Listen. A ray of light from source is incidenting at the concave mirror, and the ray of light is parallel to principal axis. This ray of light is parallel to principal axis of this concave mirror, yes or not? Always a ray of light parallel to principal axis in concave mirror, after reflection it will pass through principal focus. ये रे ऑफ लाइट पैरेलल है प्रिंसिपल एक्सिस के, रिफ्लेक्शन के बाद ये किससे पास करेगा? फोकस से। ये रूल 1 है इमेज फॉर्मेशन का। रूल 1 क्या बोल रहा? अगर रे ऑफ लाइट पैरेलल है प्रिंसिपल एक्सिस के तो रिफ्लेक्शन किससे पास करेगा? फोकस से। हमेशा व्हाट इज द रूल? व्हाट इज द रूल नंबर 1 ऑफ इमेज फॉर्मेशन कॉन्केव मिरर? और रे ऑफ लाइट पैरेलल टू प्रिंसिपल एक्सिस इन कॉन्केव मिरर, आफ्टर रिफ्लेक्शन विल पास थ्रू प्रिंसिपल फोकस। ओके, रूल 2। अगेन दिस इज अ कॉन्केव मिरर, yes or not? This is pole, this is focus, this is center curvature, and this line represents principal axis. Now, what is the rule number 2 of image formation concave mirror? Listen, if a ray of light passes through center of curvature, now incident ray is passing through center of curvature. Suppose a ray of light is incidenting on mirror, which is passing through center of curvature. This incident ray is passing through center of curvature. When it strikes the surface of the mirror, it will return back on the same path. What you understand? अगर कोई रे ऑफ लाइट सेंटर ऑफ कर्वेचर से जा रहा, वो वापस उसी पाथ से रिटर्न हो जाएगा, है ना? अगर रे ऑफ लाइट सेंटर ऑफ कर्वेचर से जा रहा, मिरर से रिफ्लेक्शन के बाद वो वापस उसी पाथ से क्या होगा? रिटर्न हो जाएगा। व्हाट इज द रूल 2 ऑफ इमेज फॉर्मेशन कॉन्केव मिरर? अ रे ऑफ लाइट पासिंग थ्रू सेंटर ऑफ कर्वेचर विल रिटर्न बैक ऑन द सेम पाथ एज ऑफ इंसिडेंट रे। ऐसा इसलिए क्योंकि जो भी रे ऑफ लाइट सेंटर कर्वेचर से जाएगा वो मिरर के सरफेस परपेंडिकुलरली फॉल करेगा, और अगर कोई रे ऑफ लाइट परपेंडिकुलरली किसी सरफेस पे फॉल करता है वापस उसी पास पे क्या होगा? रिटर्न हो जाएगा। रूल नंबर 1 समझ में आया? अगर रे ऑफ लाइट पैरेलल है प्रिंसिपल एक्सिस के तो वापस उसी पास से क्या हो रहा है? रिटर्न हो रहा है। अगर रे ऑफ लाइट सेंटर कर्वेचर से जा रहा है वो वापस उसी पास से क्या होगा? रिटर्न हो जाएगा। रूल नंबर 3। रूल नंबर 3 इज कन्वर्स ऑफ रूल 1। व्हाट यू हैव स्टडीड रूल 1? If a ray of light is parallel to principal axis, it is passing through principal focus. And rule number 3, a ray of light is passing through principal focus. Now, the incident ray is passing through principal focus. This incident ray passing through principal focus. After reflection from the mirror, the reflected ray will become parallel to principal axis. ये बात समझ में आया? अगर ray of light focus से जा रहा, अगर इंसिडेंट रे फोकस से पार करते हुए मेरे कॉन्केव मिरर को स्ट्राइक कर रहा, वो उसका रिफ्लेक्टेड रे क्या होगा? वो पैरेलल हो जाएगा। किसके पैरेलल हो जाएगा? प्रिंसिपल एक्सिस के, है ना? रूल नंबर 3, इफ अ रे ऑफ लाइट इज पासिंग थ्रू फोकस ऑफ अ कॉन्केव मिरर, it will become parallel to principal axis. And lastly, rule number 4, इरेज करना पड़ेगा क्या? Rule 4. Again, a spherical mirror is taken. This is pole. This line is representing principal axis. This is focus, and this is center of curvature. Now, the ray of light is incidenting at the pole of a concave mirror. Suppose from source of light, a ray of light is falling like this. That's incident ray incidenting at the pole of a concave mirror. The incident ray making any angle with the principal axis. Let this be angle of incident. Whenever a ray of light is incidenting at a pole of concave mirror, the reflected ray return back making same angle with the principal axis, such that angle I will be equal to angle R, है ना? अगर रे ऑफ लाइट पोल पे इंसिडेंट कर रहा तो प्रिंसिपल एक्सिस से इंसिडेंट कुछ ना कुछ एंगल बना रहा, रिफ्लेक्टेड रे भी सेम एंगल बनाता हुआ प्रिंसिपल एक्सिस से रिटर्न कर जाएगा। ये रूल नंबर 4 है इमेज फॉर्मेशन का। किसमें? concave mirror में। What is the rule 4 of image formation in concave mirror? A ray of light incidenting at pole of a concave mirror return back making same angle with the principal axis. These are the 4 law of image formation concave mirror. I am concluding. I am briefing this concept again. Consider here. Suppose this to be a concave mirror. This is pole, this is focus, this is center curvature, and this line is representing principal axis. What is the rule 1 of image formation concave mirror? If a ray of light is parallel to principal axis, it will pass through principal focus. Yes or not? This ray of light is also parallel to principal axis. Again, this will pass through principal focus. This is rule 1 of image formation concave mirror. Rule number 2. What is rule 2 of image formation concave mirror? If a ray of light, if incident ray passing through center curvature, it return back on the same path. Let this be an incident ray. This incident ray passing through center curvature, it will return back on the same path. Again, let this to be an incident ray. This incident ray again passing through center curvature, it will return back on the same path. What is the rule 2 of image formation concave mirror? Whenever a ray of light is passing through center curvature of a concave mirror, it will return back on the same path. This is rule 2 of image formation concave mirror. Again, rule 3. Here it is drawn. If a ray of light is passing through principal focus of a concave mirror, it will become parallel to principal axis. Whenever a ray of light is passing through a principal focus of a concave mirror, it will become parallel to principal axis. है ना, ये ray of light parallel, ये ray of light focus से जा रहा है, ये parallel हो रहा है principal axis के, ये ray of light focus से जा रहा है, ये parallel हो रहा है किसके, parallel हो रहा है principal axis के. And what is the rule 4 of image formation in concave mirror? If a ray of light is incidenting at a pole of concave mirror, now from source of light, a ray of light is falling on the pole of a concave mirror, it will return back making same angle with the principal axis, such that angle I equal to angle R. Based on Day's law, we will do the image formation. Particularly this law is quite important. We will use this law in every case. This law will be used in one case, and this law will be used in case number 4. You can recapitulate it. Now we will go through the image formation in concave mirror, but before going through the image formation in concave mirror, let us come to a discussion. This discussion will be particularly more important when you do the numericals related to a spherical mirror. Listen, this is a concave mirror now. This is pole, this is focus, and this is center curvature. This line representing principal axis. Now listen, always an object is placed in front of concave mirror. Okay, now what could be the possible position of object? Of course, an object can be placed at any point lying between pole and focus. Case number 1. The object can be placed at focus. It can be placed between focus and center curvature. It can be placed at center curvature. It can be placed beyond center curvature, and it can be placed far apart from the mirror, i.e. at infinity. What is the possible case? Case 1, case 2, case 3, case 4, case 5, and lastly case 6. What are the 6 cases of image formation in concave mirror? The object can be placed between pole and focus. It can be placed at focus. It can be placed between focus and center curvature. It can be placed at center curvature. It can be placed beyond center curvature. It can be placed at infinity. Now listen, an important discussion. A concave mirror is widely used mirror. Why concave mirror is widely used mirror? You have studied the characteristics of plane mirror. For any position of object, a plane mirror always produces a virtual erect image. It produces an image of same size as that of object. Okay. But a concave mirror can produce either virtual image, either real image. It can either produce erect image, it can produce inverted image. It can produce an image magnified, diminished, or of same size as that of object for different position of object. Okay, listen. For a concave mirror, a center of curvature of a concave is quite an important point for a concave mirror. Until an object is placed before center of curvature, the height of image will be more than the height of object. जब तक एक ऑब्जेक्ट सेंटर ऑफ कर्वेचर से पहले रखा गया, हमेशा इमेज का हाइट ऑब्जेक्ट के हाइट से बड़ा होगा. इस केस के लिए मैग्निफिकेशन 1 से ज़्यादा बड़ा होगा, और ऐसी इमेज को हम मैग्नीफाइड इमेज बोलेंगे. कब? जब तक ऑब्जेक्ट सेंटर ऑफ कर्वेचर से पहले रखा गया. Once an object is placed at center of curvature, the height of image will be same as the height of object, and for such an image, the magnification will be 1. It means the height of image will be same as the height of object. And once an object is placed beyond center of curvature, at any position, the height of image will be less than the height of object. For such an case, magnification will be less than 1, and image will be diminished. Yes or not? एक कॉन्केव मिरर मैग्नीफाइड इमेज फॉर्म कर सकता, सेम साइज इमेज फॉर्म कर सकता, और डिमिनिश इमेज फॉर्म कर सकता. कब? एक ही पोजीशन के ऑब्जेक्ट के नहीं. जब तक एक ऑब्जेक्ट पोल और सेंटर कर्वेचर के पीछे कहीं भी रखा गया, वो हमेशा इमेज का साइज बड़ा होगा ऑब्जेक्ट के साइज से. उस इमेज को हम क्या बोलेंगे? मैग्नीफाइड. एक और ऑब्जेक्ट को हम सेंटर कर्वेचर पे रख रहे हैं, इमेज और ऑब्जेक्ट का साइज सेम होगा. और एक और ऑब्जेक्ट को सेंटर कर्वेचर के बाद रख रहे हैं, हाइट ऑफ इमेज लेस देन होगा हाइट ऑफ ऑब्जेक्ट. उस इमेज को हम क्या इमेज बोलेंगे? डिमिनिश. तो हम तो ये देख पा रहे हैं कि कॉन्केव मिरर कैन प्रोड्यूस मैग्नीफाइड इमेज एंड इमेज ऑफ सेम साइज एट दैट ऑफ ऑब्जेक्ट एज वेल एज डिमिनिश इमेज एट द सेम टाइम. और कॉन्केव मिरर कैन आल्सो प्रोड्यूस रियल एज वेल एज वर्चुअल इमेज until, listen carefully, until an object is placed before focus of a concave mirror, the image will be virtual, and such a case magnification will be positive. And for the remaining case, whenever an object is placed before focus of a concave mirror, the image will be virtual and magnified. And for other case, and whenever an object is placed beyond focus of a concave mirror, the image will be real and inverted. Based on this discussion, we will draw the image formation for this 6 case in concave mirror, and then we will note down the property of image form. And this concept are quite important. सबसे बेहतर तरीका है, एक फ़ायदा है मिरर के न्यूमेरिकल के कि हम इसके आंसर को हम क्रॉस वेरीफाई कर सकते हैं. यही सब कंसेप्ट्स हैं. हम आगे भी कंसेप्ट बताएंगे, लेकिन ये तुमको ख्याल रखना चाहिए कि मैग्नीफाइड इमेज कब फॉर्म होगा, डिमिनिश कब फॉर्म होगा, और सेम साइज इमेज कब फॉर्म होगा. अब हम इमेज फॉर्मेशन कर रहे हैं. तुम प्रेडिक्ट करो कि फर्स्ट केस क्या होगा इमेज फॉर्मेशन का. फर्स्ट केस क्या होगा इमेज फॉर्मेशन का? 6 केस क्या क्या है. फर्स्ट केस ये होगा, व्हेन एन ऑब्जेक्ट इज प्लेस्ड बिटवीन पोल एंड फोकस ऑफ अ कॉन्केव मिरर. Second case, when an object is placed at focus of a concave mirror. Case number 3, when an object is placed between focus and center of a convex mirror, concave mirror. When an object is placed at center of curvature of a concave mirror, then beyond center of curvature, and lastly at infinity. Case first. In first case, the object having placed between pole and focus of a concave mirror. Now let this to be a concave mirror. Now listen, the basic construction parameters, how will you construct? This line represents principal axis. At equal distance, first you have to draw a focus, and at equal distance you have to draw a center of curvature. This line is representing focus and this point is representing center of curvature. Yes or not? Now listen, this is principal axis. What is the position of object? The object is between pole and focus. Let this be the object. The object having placed between pole and focus, let A be the top position of object and B be the bottom position of object. Yes or not? Now listen carefully. Rule number 1. What is the rule 1 of image formation concave mirror? A ray of light parallel to principal axis. From source of light passing through a ray of light is passing through which is parallel to principal axis, it will pass through focus. Whenever a ray of light is passing through principal axis, it will pass through focus, and for image formation at least 2 reflected light rays are taken. Consider rule number 2 of image formation concave mirror. What is rule 2 of image formation concave mirror? A ray of light passing through center of curvature of a concave mirror return back on the same path. Yes or not? ये इंसिडेंट रे सेंटर ऑफ कर्वेचर से पास कर रहा है, ये वापस से पास पे रिटर्न हो जाएगा. ए से 2 रिफ्लेक्टेड रे है, एक पैरेलल था इंसिडेंट रे, उसके लिए ये रिफ्लेक्टेड है, एक सेंटर ऑफ कर्वेचर से इंसिडेंट है, उसके लिए ये रिफ्लेक्टेड है. क्या दोनों रिफ्लेक्टेड का एक्चुअल इंटरसेक्शन हो रहा है? क्या यहाँ पे फिर से रियल इमेज का फॉर्मेशन हो रहा है? क्या यहाँ पे एक्चुअल इंटरसेक्शन हो रहा है? ये 2 रिफ्लेक्टेड डाइवर्जिंग है, यहाँ पे एक्चुअल इंटरसेक्शन नहीं हो रहा, यहाँ पे रियल इमेज का फॉर्मेशन संभव नहीं है. वर्चुअल इमेज के फॉर्मेशन के दोनों रिफ्लेक्टेड लाइट को हम जब पीछे की ओर एक्सटेंड कर रहे हैं, ये इस पॉइंट पे इंटरसेक्ट करता हुआ दिख रहा है. इमेज का फॉर्मेशन किस पॉइंट पे हो रहा? इस पॉइंट पे. ये ए डैश टॉप पोजीशन इमेज का और ये बी डैश बॉटम पोजीशन इमेज का. ये बात समझ में आया? क्या इमेज फॉर्मेशन समझ में आ रहा है? फिर से बता रहे, ध्यान से सुनो. पोल और फोकस के बीच ऑब्जेक्ट को रखा गया. ए टॉप पोजीशन है, बी बॉटम पोजीशन है. सोर्स ऑफ लाइट से एक रे ऑफ लाइट पैरेलल है प्रिंसिपल एक्सिस के. रिफ्लेक्शन का ये फोकस से पास कर रहा. रूल नंबर 2, सोर्स ऑफ लाइट से एक रे ऑफ लाइट ए से पास कर रहा है, तो सेंटर कर्वेचर से भी पास कर रहा, ये वापस ही पास पर रिटर्न होगा. अब दो रिफ्लेक्टेड मिल रहा, ये का एक्चुअल इंटरसेक्शन तो नहीं हो रहा, ये डाइवर्ज कर रहा, तो यहाँ पे एक्चुअल इंटरसेक्शन में यहाँ पे रियल इमेज का फॉर्मेशन नहीं हो रहा. वर्चुअल इमेज के दोनों के रे ऑफ लाइट को वर्चुअली मिरर के पीछे को एक्सटेंड कर रहे हैं, वो इस पॉइंट पे वर्चुअली अपीयर करता हुआ प्रतीत हो रहा, इस पॉइंट पे इस तरह इमेज का फॉर्मेशन हुआ. ए भी क्या रिप्रेजेंट कर रहा? ऑब्जेक्ट. और ए डैश बी डैश क्या रिप्रेजेंट कर रहा है? इमेज. क्या इमेज फॉर्मेशन कोई प्रॉब्लम? कॉपी में खुद ब खुद करना पड़ेगा, नहीं तो फिर एग्जाम में नहीं बन पाएगा. अब प्रॉपर्टी नोट करते हैं. बेसिकली स्फेरिकल मिरर के प्रॉपर्टी में हम बेसिकली 3 चीज़ को लिखते हैं. पहला पोजीशन ऑफ इमेज, फिर नेचर ऑफ इमेज और रिलेटिव साइज. पहला पोजीशन के लिए बात करें. फिर व्हाट इज द पोजीशन ऑफ इमेज? इट इज फॉर्मिंग इन फ्रंट ऑफ द मिरर और बिहाइंड द मिरर. Yes, the image is forming behind the mirror. What is the position of image? Whenever an object is placed between pole and focus of a concave mirror, the image will be formed behind the mirror. Now, point number 2. What is the nature of image form? It is real or virtual? क्या एक्चुअल इंटरसेक्शन हुआ रिफ्लेक्टेड लाइट रे का? नहीं, वर्चुअल इंटरसेक्शन हो रहा. या फिर पॉइंट नंबर 2, क्या इमेज का फॉर्मेशन सामने हो रहा मिरर की या पीछे की ओर? हमेशा अगर इमेज का फॉर्मेशन बिहाइंड द मिरर होगा, उस इमेज को हम क्या बोलेंगे? वर्चुअल. और वर्चुअल इमेज हमेशा इरेक्ट होता. हम इसको कंसीडर यहाँ पे कर पा रहे हैं. किस तरह? क्योंकि ऑब्जेक्ट भी प्रिंसिपल एक्सिस के ऊपर है, इमेज भी प्रिंसिपल एक्सिस के ऊपर. इमेज क्या हुआ? इरेक्ट. ऑब्जेक्ट का भी टॉप पोजीशन ए है, इमेज का टॉप पोजीशन ए डैश है. ऑब्जेक्ट का बटन पोजीशन बी है, इमेज का बटन पोजीशन बी डैश है. इमेज क्या होगा? वर्चुअल एंड इरेक्ट. पॉइंट नंबर 3, मैग्नीफाइड. किसका साइज बड़ा है? ऑब्जेक्ट इमेज का या ऑब्जेक्ट का? द साइज ऑफ इमेज मच मोर देन द साइज ऑफ ऑब्जेक्ट, द इमेज हैव बीन मैग्नीफाइड. इस इमेज को हम क्या बोलेंगे? द हाइट ऑफ इमेज इज मोर देन द हाइट ऑफ ऑब्जेक्ट एंड द इमेज हैव बीन कॉल्ड एज मैग्नीफाइड इमेज. यस और नॉट? Listen, a plane mirror also produces a virtual image, but a concave mirror can also produce a virtual image whenever an object is placed between pole and focus. But the image formed in plane mirror is of same size as that of object, but image formed in concave mirror is virtual as well as magnified. ये इमेज फॉर्मेशन की प्रॉपर्टी कोई प्रॉब्लम? इमेज का फॉर्मेशन बिहाइंड द मिरर हो रहा, इमेज वर्चुअल है, इमेज इरेक्ट है और इमेज मैग्नीफाइड है. ओके, वी विल कंटिन्यू नेक्स्ट क्लास.